So once again, this being a new stream, hi, I'm Professor Cunningham. Great to see you. These links here are links to videos that will do example problems and give you excellent lectures and other things for you to use and synthesize and use to help those others that maybe need your help. I'm not going to be watching them on the stream because I think it would take too long overall, but they are excellent and you should really watch them. So we're going to start with add within 5. Now, again, these are going to go very, very quickly, but believe it or not, even as an adult, even as a 37-year-old who has been studying math as a profession for 20 years, I still feel like I would benefit from this practice right here. I think that I benefit from this practice because it's always useful to go back and check your fundamentals. So I actually do recommend that anyone of any age go back, do the early Khan Academy, and just check your habits. When I did this the last time, I discovered that I had some arithmetic habits that were bad and I needed to figure out how to change them. So anyway, let's go through this really quick. 2 plus 2 is 4. Oop, wrong button. 1 plus 1 is 2. 1 plus 4 is 5. 3 plus 2 is also 5. 2 plus 2 is 4. 3 plus 1 is 4. 1 plus 3 is also 4. That is called the commutative law of addition. We'll talk about that later. And that's it. Add within 5, easy peasy. So as promised in the Common Core outline that I did in the last stream, students are expected at the kindergarten level to be able to see an addition equation, 2 plus 2 equals, and be able to finish that equation with that 4, but they're not necessarily going to be required to write those equations themselves. As a side note, the word equation comes from the word equate or equals. It's not an equation if it doesn't have an equals in it. All right, subtracting within 5. 5 minus 4 is 1. 2 minus 1 is 1. 4 minus 2 is 2. 5 minus 3 is 2. 4 minus 3 is 1. 5 minus 1 is 4. 3 minus 1 is 2. Easy peasy. So these small numbers are honestly eventually a matter of memorization. But again, I want you very much to encourage your students or whatever young people you are helping to learn this math to use their fingers to count up or count down. That's really what they're for. And the idea of taking an addition or subtraction problem, even a very small and easy one, and breaking it down into several smaller, even easier subtraction problems, like if I'm doing 6 minus 4, I could do 6, 5, 4, 3, 2. Right? What I'm essentially doing is I'm subtracting 1 5 times, and that pattern is really important and will become very important later. All right, we are making small numbers. So again, this is the same idea. We are just putting a bit of a different spin on it. Making 5. So I want to know what number, and I'll go ahead and zoom in on this a bit, although I know that I'm kind of in the way here. I'm actually going to make myself a little bit smaller. Oh God, I'm shrinking, help me! Okay, so let's take a look. What number do I add to 3 to get 5? And what am I really asking here? And I'm going to ask you to take a moment and think about not only what is the answer, but why did you get the answer you got? I know it's 2, but how did you get that? Well, I imagine what your brain did is something along the lines of, well, 5 minus 3 is 2. So there are a few ways that I can look at this. Yes, 5 minus 3 is 2, or I can just note, hold on, or I can just note that there are 2 missing areas. I could do that. Or you could even look at this, and this is way, way later. Again, this is not necessarily a stream for kids directly, so I'm just going to go ahead and drop this on your head right now as a sort of a premonition of things to come. If instead of a blank, I put an X here, oh no, the alphabet in math, get over it, you'll be fine. What I'm doing is I am subtracting 3 from both sides of that equation, just like I was in middle school or high school, to get x equals 2. So again, don't knock these kinds of problems. They are setting up a very basic foundation for later algebraic ideas. So anyway, with that miniature rant over, 2 plus 3 is 5. 4 plus 1 is 5. It's like it's sneaking in subtraction. It's stealth subtraction. 1 plus 4 is 5. 5 is 4 plus 1, yes. 5 is 3 plus 2. 5 is 2 plus 3. And by the way, the idea that we are specifically making 5 and then later making 10 is also very powerful, and we use that a lot. There are many, many times when I have asked my grown-up friends who are professionals, and they are lawyers, and they are accountants, and they are, performers, and they are amazing people. And when I ask them how they add and subtract certain numbers, a lot of the time, this is what I get. I get people adding up to 5 and then using the multiple of 5 to get to where they need to go, or adding up to 10 and then using the multiple of 10 to get to where they need to go. These kinds of thought patterns should be very much encouraged. They should not be ridiculed. And then 5 is 3 plus 2. Okay. So that was subtracting within 5. Or that was making 5, I'm sorry. So now making small numbers in different ways. I wonder what that means. Oh, I see. So this is just, again, reinforcing the idea that we can rearrange these things. And this kind of problem right here, and in fact, I need to check and see if this problem is, no, okay, I'm doing good. This problem right here is another example of the kind of problem that you would see on social media as a, why am I making my student write the same thing over and over again? This is nonsense garbage kind of thing. You'll see that a lot. And this is not a nonsense problem. This is an excellent, excellent problem. And the reason for that is that at this level, at the kindergarten level, we need to be explicitly talking about things like the fact that 1 plus 4 is 5, specifically because, 5 minus 4 is 1. That's kind of what we're driving at here. We're showing already in kindergarten that addition and subtraction are really the same thing, just looked at sort of from different perspectives. So let's see. 1 plus 4 is 5, which means that 4 plus 1 is 5. Again, the commutative law of, or the commutative property of addition says that you can add either direction and you're fine. 1 plus 4 and 4 plus 1, they're the same thing. 3 plus 2 equals 5. 3 plus 2 equals 5. Yeah, laser drive, I know. How can we make 7? Oh, interesting. So this one's also pretty cool, I think, because there are going to be multiple answers. And all the answers are going to be underneath me. So I am, again, going to move around. I'm moving! Whoa, look at this. Oh, man, this is crazy. Anyway, so I'm going to come over here, and we're going to talk more about making 7. Well, it's 2 plus 5, yes. It's 3 plus 4, yes. But 6 plus 2 is 6, 7, 8, so that one's wrong. And again, as much as I hate to say it, these kind of multiple choice problems, even at an early age, are still important because despite the current pandemic keeping the government from making people take the SATs for college, it's still going to come back. So, sorry. Legitimately, sorry. How do we make 5 caterpillars? Well, it's 1 plus 4, and I like that they're giving, look at this, they're giving the picture so that if a student is still confused, if a student is here and still doesn't understand exactly what 1 plus 4 means, they can still just count the caterpillars and understand that it's a group of 1 and a group of 4. If you haven't watched my video on my introduction, or if you haven't watched my introduction playlist on my YouTube channel at professor-cunningham.com, you definitely should. Because instead of using caterpillars, I use rocks. But this is basically the same lecture that I gave there. How can we make 5 elephants? Well, 5 is 3 plus 2, and 5 is 1 plus 4. And again, they're taking away a little bit more of the scaffolding. Scaffolding being that support that is given to students who are figuring stuff out. They did not section these elephants off into 3 and 2 this time. It is up to the student to count. There's 3 and then 2 more. There's 4 and then 1 more. 4 plus 5 is 9. 8 plus 1 is 9. 6 plus 3 is 9. 7 plus 2 is 9. Knowing different ways to get to 9 is another really important skill, or to whatever number you want. How can we make 6? Well, I figure 1 plus 5, 2 plus 4, 3 plus 3. Hey, there's 3 plus 3. There's 5 plus 1. Hey, all 3 of them work. Those are all 6. Yay! How can we make 7 sharks? Sharks. Why does it always have to be sharks? 2 plus 5 is 7. 1 plus 6 is 7. And we are done.